This is the Brocade Campus Feature Trainer Series. I'm Terry Henry. This time around, we are going to have a look at how to configure Multi-Vrf. So I usually do my videos on the ICX 7250, but the 7250 doesn't support VRFs, and so I'm going to do it on a 6610 today. But it would be the same on a 7450, 7750, etc. Okay, so router one. So the first thing we need to do is, by default, we don't allocate any memory to VRF routes, right? And so the point of VRF, or virtual routing and forwarding, is that we're going to have separate routing and forwarding tables for multiple customers or just multiple instances that can't see each other, right? And so by default, we allocate all of the memory in the device to the default VRF, or the default routing table, if you will. And so what we need to do before we do anything with VRF is we need to reallocate that memory. So we need to take some memory away from the default VRF and give it to the non-default VRFs, right? So if I do a show default values, so on my device here, I can see, so by default, here's the default column, I have 12,000 IP routes, right? I can have a maximum of 15,000 on this hardware, but I have 12,000, and I currently have 12,000 assigned, all right? And so, so then if we look down farther, here's VRFs, so I can have a maximum of 16 VRFs by default, and that's what I do have configured currently. And then by default, I have 12,000 IP routes that we just looked at, and I have all 12,000 of those assigned to the default VRF, right? So if I do that, there is no memory available for non-default VRFs, okay? And so so the IP route VRF here doesn't get any available memory, right? So what I need to do is I need to reduce the default VRF amount to something less than the full IP route number, and then it gives me available memory. So what I've done is I've reduced that to 8,000, and I'll show you how I did that in a second. So that gives me 4,000 available routes that I can allocate to non-default VRFs. And then instead of allocating 1,000 per VRF, I've allocated 512. So that's obviously up to you, right? Your VRF may only need a couple of routes, right? It may only need, 100 routes, let's say. So you don't have to set it to 512. That's just what I chose. And so that gives me room for, however many, 7 or 8 VRFs in there that I can fit into memory, okay? So the way we do that is with the system max command. So under system max here, I did an IP route default VRF, so I changed it from 12,000 to 8,000, and then I changed the IP route VRF to 512 per non-default VRF. So that could be smaller. So if you wanted all 16 VRFs, you could reduce this to a small number, or you could reduce this substantially. Because maybe your default routing table, your default VRF doesn't need any routes anymore, right? Maybe you're going to allocate it all to non-default VRF. So anyway, you can adjust those numbers accordingly, but that does require a write memory and a reload. So when you change those parameters, it's going to tell you that you need to write memory and reload. So for example, if I do a system max IP-route-default-VRF, and I'll change it, VRF, and I'll change it to, say, 5,000 routes, for example, right? It's going to tell me that I have a total of 12,000 available, because that's my IP route number, and then I've configured for a maximum of 5,000, and so I've got 7,000 available for non-default VRFs. But then it's also saying, in order to do that, you need to do a write memory and a reload before that takes effect, because it's got to reallocate all the memory on the CAM. So just be forewarned that before you start, that's an important thing that you need to go through, and you do need a reload to make that happen. All right, so assuming that's happened, then we got to create our VRFs, right? So we do a VRF, give it a name. So I'm going to call my VRF customer A. Okay, so now I have a VRF called customer A. So the first thing I have to have is something called a route distinguisher. And a route distinguisher, or an RD, is exactly as the name implies, it distinguishes routes from the other VRFs, right? So every route that is learned in or sent by this VRF is going to get tagged with this route distinguisher. So this route distinguisher can be an AS number, colon, and then some arbitrary number, or it could be an IP address, colon, then an arbitrary number. So, it doesn't really matter. I don't have a real assigned BGP AS number or anything, so I'm just going to make something up. So I'm going to do an RD 10:10. And optionally, I can set a router ID that belongs to this VRF. So you don't have to do this. I'm going to do it. So I'm just going to make it 1.1.1.1. Your router ID, as always, doesn't have to be a real address, right? And then the other thing you have to do, this is a requirement, is you have to tell it that it's IPv4 or IPv6 for an address family. But if you don't do that, it won't let you assign it to an interface later. So that's one thing you need to do. And then we're going to do an exit VRF to get out of there. And then I'm going to build a second one called customer B creatively. RD 11:11. It doesn't matter as long as it's unique from the other ones. We will assign it a router ID as well. Can't be the same router ID. Well, I guess it could. And then same thing, address-family, IPv4, and then exit VRF. Okay, so we've got our two VRFs assigned, right? Customer A, customer B, different route distinguishers, different router IDs. So then I'm going to actually, before I do anything further, I'm going to turn on OSPF. So router OSPF, and instead of just hitting enter and going router OSPF and putting in the default VRF, I want to configure OSPF for a specific VRF. So we're going to say customer A, and then I'm just going to do an area 0, right? Exit there, and do the same thing for customer B. Okay, so I've got two different OSPF instances. They're both in area 0, but they're never going to be able to see each other, right? So that's the beauty of VRF, is that they are truly separate routing tables and forwarding tables, and so therefore, I can have customer area 0, in every single VRF if I want, and none of them will be able to see each other, right? So the same thing with IP addresses. I can have overlapping IP addresses or IP ranges in every VRF, and that's okay. That's perfectly valid within this environment. Okay, so I've got OSPF set up. Next thing I'm going to do is set up a VLAN. So VLAN 10, and we're going to tag our link between another switch, so 1/3/1. Okay, and then I'm going to assign a router interface to it called VE10. Okay, and so then under interface VE10, I'm going to take my VE10, and the first thing I'm going to do is I'm going to assign that VE, that virtual interface, to a particular VRF. So VRF forwarding, and then customer A. Okay. So had I have put IP addresses on this interface already, when I do that VRF forwarding customer A, it would have deleted all my IPs. So do the VRF first and then do your IP addresses, or else it's going to frustrate you down the road. So I'm sure you will learn that the hard way sooner or later. So I'm going to give it an IP 10.0.0.0.1.24, and I'm going to give it a second one just so we can see the differences between the routing tables /24. And then I'm going to assign it to IP OSPF area 0. Okay, then I'm going to create a second VLAN, VLAN 20. I'm going to tag the same port E1/3/1. That would help. Okay, I'm going to assign a router interface called VE20. interface VE20, VRF forwarding. Now I could assign it to the same VRF, but in this case I want to assign it to customer B. Okay, and then I'm going to assign it the same IP address, right, which normally would not be allowed, right? If you were in the default VRF or the default routing table, you couldn't do that. But because I'm in separate routing tables, I'll show you that it takes that no problem, right? Yeah, otherwise, if I hadn't been running VRF, it would have told me right there that there was an IP address overlap and or a duplicate, and it would have refused to take that command. Okay, so I've assigned that. All right. So let's have a look at what we got here. So we have our two VLANs created. We've got a VE on each one of them. I've got the same port tagged. I built my two VRFs, right? Customer A, customer B, different route distinguishers, different router IDs. I turned on OSPF on both of those. So VRF customer A, VRF customer B, same area. And then I assigned VE10 10.0.0.1/24, and I also assigned 10.0.0.1/24 to VE20, both running OSPF. And then there's a second interface here. So that's it for this guy. Then I'm going to drop over to another router, and we are going to configure almost an identical configuration on router B. So you can see that I've already done the system max and reloaded these. I didn't want to have to wait for a reload, so I've already got that part of the configuration done. Okay, so then we're basically going to do the same thing. So we're going to do a VRF customer A. I'm going to give it the same route distinguisher, 10:10. Now I'm going to give it a different router ID, obviously. For OSPF purposes, if it sees its own, its router ID as a duplicate, it's not going to create a neighbor relationship. And then we're going to do an address-family, IPv4, and then an exit-VRF. Okay, so that's that one. Create my second one called customer B. Give it the same route distinguisher as customer B on the other router. A unique router ID, 2.2.2.2, address family, IPv4, okay, and then an exit VRF. Okay, so then we're going to turn on OSPF just like we did on the other one, exactly the same commands here. Customer A, area 0, B, area 0. Okay, so I got OSPF turned on, so identical configuration to the other one. Then we're going to create our VLANs just like we did in the other router. So create my VLAN. I'll just save myself a little bit of time here. Okay. Then I'll create 20 while I'm at it here. Okay, so VLANs are identical to the previous router, right? So then we need to build our VEs. Okay, so interface VE10 here. So it's just again, we're going to assign it to a VRF. So VRF forwarding called customer A. Okay, and then assign my IP address. So 10.0.0.2 in this case. Okay, and then and then I need the second one, IP address 172.16.0.2/24, and IP OSPF area 0 to assign it to OSPF area 0, and that's it for that one. And then interface VE20, VRF forwarding customer B, IP address. So again, I'm going to have a duplicate IP here, but it's not really a duplicate IP because it's in a completely separate routing table. And IP OSPF area 0. Okay, so we're pretty much the same, different IP addresses, but otherwise it's identical to the other configuration. I'm going to do one additional thing here on this router. I'm going to do an interface loopback 1, and I'm going to assign my loopback 1 to VRF forwarding, let's see, customer, we'll assign it to customer B. Okay, and then we're just going to put some /32 IPs on it just to see what happens on the other router. So IP address 20.0.0.1/32, 2/32, 3/32, and one more. All right, and then we will assign it to OSPF area 0. Okay, so if I drop back over to router 1, we'll see what we got here. So first we're going to do a ShowVRF. So ShowVRF says I've got two VRFs configured, right? So I've got customer A with a route extinguisher of 10:10, and I have IPv4 routes. I have two IPv4 routes here. I have 5 IPv4 routes under 11.11, right? And so VE10 is assigned to customer A, VE20, and so I've got a total of 7 non-default VRFs in IPv4, and I have 0 IPv6. So obviously the IPv6 configuration is, identical. It's just with IPv6 addresses rather than IPv4, and your address family is going to be IPv6. Okay, so that's obviously up and working, right? I have 2 different route tables. So let's have a look at that. So if I do a show, first, if I just do a show IP route, I have nothing, right? So my default routing table or my default VRF doesn't have any routes in it currently at this point. So if I do a show IP route VRF customer A, what do I got? Well, so I actually have 10.0.0.0/24, 172.0.0.0/24, right, in customer A. So 2 routes there. Now let's have a look at customer B. Okay, so totally different routing table. So this 10.0.0.0 is not the same as this 10.0.0.0, and in fact those two can't see each other, ping each other. There is no connectivity. They are completely separate, overlapping on the same device. I also have learned through OSPF the 20.0.0.1/32, 2, 3, 4. So for my loopback on my other device, I learned those through OSPF, but you'll see that VRF customer A has no knowledge of those, right? So there's no ability to route from one VRF to the other, at least at this point. We can also see show IP OSPF VRF customer A, for example. Sorry, I was looking for neighbor. So here's my neighbor table for customer A, and here's my neighbor table for customer B. So even though I see a neighbor of 10.0.0.1 here, that is a completely different neighbor, right? You can see the router ID comes from that VRF, right? So it's advertising its router ID that we assigned when we built the VRF, right? So there's 2 neighbors because there's the 2 IP addresses here. There's only 1 here. So totally separate routing tables. Lastly, if we look at a show ARP, right? So there's no ARPs in the main routing table or in the default VRF. But if we do a VRF customer A, I have a routing table, an ARP table here, excuse me. And then B, I have a completely different ARP table. So even the ARP tables are totally separate, right? Okay, so and then going forward, so let's say everything is handled separately, right? So if I wanted to do a ping or a trace route or something like that, I need to now ping with the VRF command, right? So I need to ping inside of VRF, and so it would be, customer A. Let's do customer B and we'll ping 20.0.0.4. Right? So now if I try to do that same thing, if I tried to do, customer A, I wouldn't get a response because it's going out a particular VRF. And same thing, if I, without the VRF, if I just tried to ping 20.0.0.4, well, the default VRF doesn't know anything about 20.0.0.4, so it can't get there. All right, so that's the gist of VRFs, right? So you can also have a management VRF, which we'll talk about in a different video. But this is, you can have up to 16 VRFs on this hardware. Obviously, on an MLX, you can have many more, or a CER or something like that. But pretty straightforward, good for service provider, hosting providers, or even inside an enterprise data center if you're trying to for security reasons, you're trying to build completely different routing tables with, overlapping instances. You can run OSPF or BGP or any routing protocol, static routes inside your VRF, and they can't see each other. All right, so that's it for today, and thanks for joining. Appreciate it.